Hello guys, welcome to my YouTube channel. In today's video, I would like to explain three things. Number one, what is a thermocouple? Number two, how does it work? And number three, what's the difference between a thermocouple and a PT100 RTD? Okay, before we explain that, let's just look at the components in front of you. On the left, we have a Flux 789 process meter. That's an instrument that is used to measure voltage, AC and DC voltage. It's also used to measure resistance. It can also measure current, both current in amps as well as in milliamps. Then you can also use it to source current in milliamps. And then next to a Flux 781 process meter, we have a thermocouple, the component that we are going to talk about today. Here is the thermocouple, this component. And then next to the thermocouple, we have a beamex multifunction instrument. This instrument can be used for measuring. If you can see, I've got meter for measuring. And then you can use it as a calibrator. You can use it as a documenting calibrator to record and save data like a database. And then you can use it as a device communicator to communicate with other devices. Yeah, it's a very useful instrument in instrumentation and automation industry. And then after that, we've got a PT100 RTD. This one, I just brought it for demonstration since we're going to talk about the difference between an RTD and a thermocouple. All right, let's get into the thermocouple quickly. A thermocouple is a temperature sensor that is based on two metal alloys that are fused together. The word thermocouple, that we all understand that couple means two. So it's two dissimilar metals. The metals are not the same type, they are fused together. So those metals, they expand at different rates, and as they expand or contract under temperature, they generate voltage, and then that voltage can be used to display the temperature. But basically, if we are being asked what is a thermocouple, thermocouple is a temperature sensor that is based on a principle of two metal alloys, two dissimilar metal alloys fused together. That's all. And then how does it work? As we know that when metals are exposed to temperature, they either expand or contract. So because it's two dissimilar metals, they expand and contract at different rates. But the rate of change of the voltage that is generated between those two dissimilar metals is directly proportional to the change in temperature. That's what makes it possible for us to use. So the one in front of us is a type K thermocouple, and we can see by the color coding, it's got yellow and red, and it's made of two alloys. It's a nickel chromium and a nickel aluminum, but you don't have to cram these things. They are all readily available online. But the point I want us to get to is that the two metals, when we take this instrument and expose it to a hot environment, it will generate a voltage, and the higher the temperature, the higher the voltage that will be generated. And what is interesting is that voltage is directly proportional to the change in temperature. So because of that, we are able to use this device or this component to measure temperature. A thermocouple is usually used in industry to measure very high temperatures, like in devices like ovens, furnaces, and the like. And so, but the way it works, the more the metals are heated up, they expand, and as they expand at different rates, and then that expansion creates a millivolt or a voltage, but that voltage is very small. So that change in voltage is linear, and it is similar to the change in current. Sorry, similar to the change in temperature. Okay, we're gonna have a look at that shortly. So that is how a thermocouple works. That's what makes it possible for it to be able to measure the temperature. And like I explained in my previous video, these sensing elements, most of the time, they generate a very small change in voltage or change in current. That is why there is a need for an amplifier to amplify that small signal to something that can be displayed or something that can be used to control. For example, in a case of a thermocouple, you can use it to control the heaters or to control how much gas is flowing into a furnace, depending on what is being controlled. So that signal is usually very small, but it's being amplified. Okay. Before we go there, let's just explain a quick difference between a thermocouple and a PT100. I have a previous video that I uploaded. I will share the link shortly. That video explains how a PT100 works. A PT100 is based on a principle of resistance. If you look at its wire, it's going to have 3 wires, 2 reds and 1 white. So, but it is basically a resistor. So when you are dealing with PT100 RTD, you are talking about resistance. But when you are dealing with thermocouples, you are talking about millivolts of voltage that is being generated. Both are used to measure temperature. So the difference, a PT100 is in terms of application, because sometimes the physical appearance will look the same. But the difference, a PT100 will usually have 3 wires, even though we'll find PT100s with 2 wires or 4 wires. But when you measure between the 2 points of a PT100, you're going to get a resistance value. And that resistance will change as the sensor is being heated up. Whereas in the case of a thermocouple, you will always get two wires with different colors, depending on the type of the thermocouple you are working with. And when you measure there, you will get a very small voltage in terms of in millivolts. But as you heat it up, those millivolts will go up and increase and increase and increase. Okay, that's the main difference. And also in the application, a PT100 RTD is usually used for low temperature applications, 0 to 100 degrees, 150 degrees. It's not usually used at temperatures that are very high, let's say 300 degrees, 400 degrees, unless it's specifically designed for that purpose. So that's the main difference. And then the accuracy as well, it's very good accuracies at lower temperatures, even sub-zero temperatures, meaning negative temperatures. But with thermocouples, they've got a working range. We'll find maybe a specific type of a thermocouple is good for 300 to 900 degrees as an example, and then you get a different type of a thermocouple that is good at temperatures, let's say 1000 to 3000 degrees and so on. So depending on the application, you will choose which type of temperature sensor you are using. Okay, I think I covered all 3 questions, but as an extra, let's just go into the beamex calibrator and look at the values that I'm reading from the 2 temperature sensors. This side, I have my RTD. It's connected using these wires, so it's connected there. But this side, I've got my thermocouple, and it's connected on this port. This port is for thermocouple. Okay, so now inside my calibrator, I can just go inside the meter, and then I've got a lot of options in front of me. For the thermocouple, I already went to TC, but I can also just look at the voltage, how much voltage I'm getting there. If you see, I'm getting negative 0.295. So if I start to heat up my thermocouple, that resistance value should change. As you can see, the value of resistance is changing. It's going up because you see it was minus 27, now it's minus 21. It's gonna go to 0 and so on and so on. That's just an example. Okay, but the temperature that is displaying now, it's 23 degrees. Remember, I was warming it up. And then this side, I've got my RTD. If I look at my RTD, I can just press here and look, the temperature of that RTD is 22. Remember, I didn't warm it up. And then as I warm it up with my hands, the temperature is going up. But we can also look at the resistance value. It's 109 volts, not 109 ohms, sorry. As I heat it up with my hands, the resistance is increasing gradually. So basically, this just explains that, okay, a PT100 RTD is based on resistance. It's also a temperature measuring device because you can read temperature. There's the temperature. As I heat it up, you can see the more I touch it, the temperature is going up as I heat it up. We can even use boiling water, but for the sake of this exercise, I just wanted to show you the small changes that it experiences as it is getting heated up. Okay, but if we look at the thermocouple, it's still on 23 degrees. I can continue heating it up. As I heat it up, you can see with my hands are warmer than 24. Remember, my body temperature should be in the 30s. So as I touch this thing, it's getting to my body temperature, it's warming up. And as you can see, you can even see the millivolts, the voltage millivolts value, it's going up. So yeah, you do get tables online for both the PT100. You can just go Google the PT100 table. Then it's gonna tell you exactly at what temperature, at 29 degrees, you should be getting so many ohms on the PT100 RTD. Then you also got tables for thermocouples. Obviously, it's also gonna tell you that at so much, at 28 degrees, you're supposed to be getting so much voltage. Then that's how you will know that your instrument is functioning properly. Those are the values that you can use to calibrate your sensor. Remember, when we calibrate, we do calibration of the sensor, but we also calibrate the transmitter. Okay, I think I've covered enough for today. Thank you for watching up until this point. If you've got any questions, please do post them under the comment section. And if you like the video, please do press like, do share the video with someone who will find it beneficial. And also, please do subscribe to the video. Thank you so much for watching. Enjoy the rest of your day. Goodbye.